This tutorial is going to talk about solving exponential equations. So these are equations where the variable that you are essentially trying to solve for is in the exponent of the equation. So the steps are outlined right here. The first thing that we want to do is isolate the exponential expression on one side of the equation. So for instance, in this first example, 3 to the x plus 2 power is already isolated. There's nothing on the outside of that piece of expression. Versus 8e to the 2x power, the exponential expression is just this. So since it's being multiplied by 8, it's not at this point isolated. So in order to isolate that, we would have to divide both sides by 8. So that e to the 2x power would equal 20 divided by 8, or we can reduce that to 10 over 4, which then reduces to 5 halves. So you could say 5 halves, or if you wanted to write 2.5, because that is still exact, you could do that as well. So both of these examples are now set up so that step 1 is done, where the exponential expression is completely isolated. The next thing is we want to take the logarithm of each side. And a lot of times people will, as they work through this, they say multiply by log. That doesn't make sense. You can't multiply by log. You are taking the logarithm of each side. And which logarithm you use is dependent on the equation. So if your equation has an exponential expression with an e, like this one, then it's going to make the most sense to take the natural log of both sides. However, if it doesn't have an e, it makes the most sense to take the common log, or log base 10 of both sides. You can technically choose a log of any base, but you're going to probably have to do some calculator work, so it's smart to choose the logarithm with either a base e or a base 10 because those are the buttons on your calculators. So whatever you do to one side, you have to do to the other. So in this case, if I were to take log base 10, so the common log of 3 to the x plus 2 power, I would also have to take the common log of 7. Over here, if I would take the natural log of both sides, the natural log of e to the 2x equals the natural log of 2.5. The reason that this is helpful is because as soon as you've rewritten these in terms of logarithms, we had a rule that said if you were taking the log of, let's say, base a of b to the c power, then this is the same thing as c times the log base a of b. So that exponent becomes a factor that you're multiplying the logarithm by. So since the entire exponent here is x plus 2, we could move that and say you are multiplying by that quantity. So I'm going to put it in parentheses. So this would be the quantity x plus 2 times the log of 3 equals over here the log of 7. Over here, this would become 2x times the natural log of e equals the natural log of 2.5. So how are we going to solve for x here? Well, remember the log of 3, the log base 10 of 3, this is just a number, right? We're essentially asking 10 to what power is 3, and you're going to get some number here. In this case, we know it would be a decimal, but we don't know exactly what it is. We would have to use our calculators to get this. But if you had the expression something like x plus 2 times 9, we know that all you have to do to get the x plus 2 by itself is either you could distribute the 9, but let's say if it equaled 27 or something like this over here, you could just divide both sides by 9 to get the x plus 2 by itself, and then you could solve for x by subtracting the 2. So let's do the same thing over here. Let's divide both sides by log of 3. This means that you would have x plus 2 equals the log of 7 divided by the log of 3. Again, this is going to be a decimal that we'd have to get with our calculators. But then to isolate x, which is the last step of our equation, we would just subtract 2 from both sides. So it would be the log of 7 divided by the log of 3, and then that quantity minus 2. So if we use our calculators, the log of 7, you could hit enter here if you wanted, divided by the log of 3, hit enter, and then we need to subtract 2 from that quantity, and we're going to get negative point, and let's say, I think the instructions said round to the nearest, 4 decimals? So 1, 2, 3, 4 decimals is right here. It's a 5 after, so we would say this is negative 0.2288. So the approximate answer here is about negative 0.2288. Now over here, again, we want to isolate x. I will point out that the natural log of e, remember the natural log of e, you're essentially saying log base e of e. So you're saying e to what power is e? Well, that's going to be a 1. So the natural log of e is just 1. So 2x times 1 is just 2x. So 2x equals the natural log of 2.5. So to isolate x, we would say this is the natural log of 2.5 divided by 2. So in our calculators, the natural log of 2.5, that quantity divided by 2, we get 0.4581. So our approximate answer is about 0.4581.